So, I am Dr.R.Eswaramoorthi, Professor, AC Department, KSR College of Engineering, Tiruchengodu. Today, I am going to take a session in the topic of embedded system. What is an embedded system? According to the Institution of Electrical Engineers, a general purpose definition of embedded system is that they are devices used to control, monitor and assist the operation of equipment, machinery or plant anything. So, embedded reflects the fact that they are an integral part of the system. An embedded system is a special purpose computer system which is completely encapsulated by the device it controls. An embedded system has a specific requirements and performs predefined tasks unlike a general purpose processor, that is a personal computer. Microcontrollers are used in embedded system. So, embedded systems are a combination of hardware, that means a microcontroller, and a software, that is assembler, C, C++, to perform a specific function. An embedded product uses microcontrollers to do one task only. So, what is a microcontroller? Microcontroller, often abbreviated as MCU, that is a microcontroller unit, is a single computer chip, that is a IC, this integrated circuit, that execute a user program normally for the purpose of controlling some devices. Hence the name microcontroller. The program is normally contained either in the second chip called EEPROM, that is a memory, or within the same chip as the microcontroller itself. For example, if the microcontroller has on-chip memory, so it has a program. If it is not available enough memory space in on-chip, that we have an external chip, that is called as the EEPROM. A microcontroller is normally found in devices such as micro ovens, automobiles, keyboards, CD players, washing machine, cell phones, VCRs, security systems and so on. So, what is the difference between microprocessor and microcontroller? So, microprocessor is nothing but a general purpose processor, but microcontroller is a specific purpose. Microcontrollers are used in devices that require some amount of computing power but don't require as much computing power as that are provided by the complex and expandium i3 system, which generally requires a large amount of supporting circuitry, large motherboards, hundreds of megabytes of RAM, hard drives, like etc. A microwave oven just does not need that much computing power. Microcontroller based systems are generally smaller, more reliable and cheaper. They are ideal for the types of applications described above, where cost and unit size are very important consideration. In such applications, it is almost always desirable to produce circuits that smallest amount of physical space require the least amount of energy and cost as little as possible. But in microprocessor, there is no memory, I/O ports, timers. Microcontroller has a memory, on-chip memory, timers and I/O ports also. So, this is the microcontroller diagram. That is the main part of the microcontroller is the CPU for generating the clock signal we need a oscillator and bus control logic to control the entire operation. We have a bus control logic, then 4 input output ports, serial port, 4 IO ports which are used for parallel communication purpose, and also we have a serial communication port, and we have 2 timers, timer 0, timer 1, and program memory, data memory, that is a random access memory is the data memory, read only memory is the program memory, and also we have interrupt facilities also in microcontroller. Some comparison between the Pentium and the 8051 microcontroller. So clock speed in 8051 microcontroller is 12 MHz. Typically 60 MHz IC is available. But Pentium 1000 MHz, that is a 1 GHz. Address bus. In 805 microcontroller we have a 16-bit address bus, and Pentium has a 32-bit address bus. Data bus, 8 bits wide data bus in 805 microcontroller, but in Pentium has a 64 bits data bus. ALU with 8 bits in 805 microcontroller, Pentium has a 32 bits. Then applications of 8051, that is a domestic applications, peripherals, automotive, etc. Then Pentium is used in personal computers and other high performance areas. Power consumption, small fraction of watt in 8051 microcontroller and tens of watts in Pentium. Cost of the chip 8051 microcontroller about Rs52 and about 6000 for Pentium. These are all the some microcontroller manufacturing companies, that is a Motorola, Intel, Zicloc, PIC, these etc. Port organization of 8051 microcontroller. Here we have a 4 ports, P0, P1, P2, P3. Port 0 has P0.02, P0.7, that is a 8 bits which are parallel communication and is a bidirectional. Port 1 is also P1.0 to P1.7 parallel communication 8 bit ports. Then port 2 P2.0 to P2.7 8 bit parallel communication. Port 3 P3.0 to P3.7 parallel communication 8 bit port. Port assignments. Port 0 is used as a IO port as well as AD0 to AD7 for external memory. That is a address data bus. AD0 to AD7 also used through port 0. Port 1 is only for IO port. Port 2 is the used for IO port and as well as higher order address A8 to A15 for external memory access. Port 3 used for dual purpose, which is used for IO port as well as some other functions. That is P3.0 is used for RxD, that is a serial communication purpose, receive data. P3.1, that is a transmit data, serial communication purpose. Then P3.2, P3.3, P3.4, P3.5 are all the interrupt signals, and P3.6, P3.7 are the write and read purpose respectively. This is sample program for alarm purpose. You have to give the data to port 3 and port 1. That is a move P3 0F, move P1 00, and the port 3 data is moved to the accumulator. Then it will be compared. Compare jump not equal A has 00. Then it will be alarm. Then sometimes then L jump pole. It will be again and again the loop will be continued up to 00. Then set bit P1.7. P1.7 will be set bit. We have to set it as a 1. Then end loop. Loop will be entered. So this is the one application. That is a block diagram of a data pointer. GPS and GPRS are connected through a microcontroller. From that we have to receive and transmit the data through a microcontroller, and it will be connected to the server, and SMS also provided. Then if we want to take a print, that our facilities are also available to take the printout. So today we completed the introduction of the embedded system, and what is embedded system, and what is the difference between microprocessor and microcontroller, and how the embedded systems are used for a particular task. Okay, thank you.